In our greenhouse here, we have a different style or different type of fertilizer mixing units here. These are more of a diaphragm pump type of system that are also very commonly used in the greenhouse industry. We still have our same stock tanks, our A stock and our B stock, that are set to be mixed at 1 to 100 in this instance. We have 3 heads on this system. This would be the head that would be doing the proportioning of the A mix. This one would be doing the proportioning of the B mix. And a third head here, if we wanted to use acidification as a separate container, we could do that. Currently, right now, we're doing the acidification in the A stock, so we don't actually need this acid injection. But oftentimes it's advisable to be able to do that so that you don't mess with the fertilizer concentrations if you only want to adjust the pH. So that's what this third head is, and it's a little different configuration than the other two, and that's the reason for that. So in this greenhouse, the water would be coming in here. We have our secondary filter system. The primary filter is out near the well. It comes in and goes through a master solenoid valve here that can turn the whole system on or off. And then the water goes up and down through here, and then these 2 proportioners are going to put the fertilizer in here for the A mix, here for the B mix, here for the acid if we were using that, and then on out to the individual zones, in this case, that go into the greenhouse. So our solenoids that run each individual zone, in this case, would be inside the greenhouse. So we could have 1, 2, 5, 6 different solenoids inside the greenhouse on this particular controller. And this controller system here would manage multiple zones very easily, no larger than our greenhouses are here. So once the injections are done, also it goes through a mixing station down at the bottom here that forces those pulses under low flow to be mixed into a chamber to unify all of that solution before it actually goes into the greenhouse. And so that's behind this 1B stock tank here. But it's an important component of this to be able to make sure that things are mixed properly before they go into the greenhouse. The other thing that this system is set up to do is to have some sensors here, and we can monitor flow, electrical conductivity, and pH on these 3 units here. So the irrigation controller, in terms of the time of the duration and when it starts and how long it's going to run, is going to be set by this irrigation controller, and all the same principles would apply there, that we want to make sure we have the capacity of this irrigation controller to manage everything for us. So it's a different type of injection system, a diaphragm pump in this particular case, but a very good injection system that has a lot of longevity to it, and has been really easy for us. Both of these types of systems have been easy for us to manage here at our center. So in a small greenhouse system, you might not need very many zones, but there is a maximum capacity that any of these irrigation systems are going to be able to handle. So in a large operation, you may need to break up that floor plan into individual zones so that you are not going to demand more water or nutrient solution than what these injectors are going to be capable of doing. So when we talk about zones, that's really what we're talking about. If you had 10,000 plants and 10,000 emitters, and this irrigation system could only do, let's say, 1,500 or 2,000 at a time, then we would need to break up that 10,000 irrigation emitters into individual zones. And all that's going to happen in that situation is that the timer or the controller is going to turn on zone number 1 and run it for 2 minutes and turn off. and then zone number 2 is going to come on and run for 2 minutes and then turn off. So it's going to go through that sequence of zones, and if they all have exactly the same demand for the duration, then that's the way that it would work. But if you had a crop, zone number 4, that needed something a little bit different, you could actually set that up so that zone number 4 runs for 3 minutes instead of 2 minutes, something along those lines. So oftentimes these units have the capacity to irrigate large areas because we can break them up into zones and manage each individual zone with its own solenoid valve. With these basic irrigation and injection systems that we're using here, there would be one limiting factor. These are going to be set to a known proportion or ratio of, say, 1 to 100. And so it can manage several different zones, 1, 2, 3, 4, 5, but each time that this system comes on, it's going to be delivering the same concentration. So I could vary the length of the irrigation event by the solenoid on the timer, but I can't change the concentration of the fertilizer when I have these 2 heads or 2 proportioners set with a single A and a single B mix. So this would work really well where I've got the same crop, everything is the same, and I need only to have one level of concentration as that crop grows up. Where it gets to be complicated is if you want to grow 3 or 4 or 5 crops in the same system and use only these proportioners. So in that event, on a larger scale operation, you probably would be necessary to add another set in or another head in here to be able to monitor. Maybe you can get by with the same A mix on everything, but you'd need 2 B mix heads, one with a low nitrogen and one with a high nitrogen, let's say, something along those lines. And then you'd have the capacity with that 3rd head to be able to do some changes there. But every time that you want to have a different concentration, it's going to require a more sophisticated system than what I have here. We could do the same thing with this particular brand or the other brand, but we would probably, in both instances, need to be able to bring in a 3rd head to be able to do the different levels of concentration. So oftentimes in our small operations where you only have 2 heads or 2 injectors, there is sort of an attempt to reach a medium balance within that. But there are some crops, for instance, if you put strawberries and tomatoes on the same system, you're probably never going to be able to do that because the requirements for the nutrition are so different, strawberries being a very low EC crop and tomatoes being a very high EC crop, that if you jump in the middle here somewhere, it's just simply not going to work. So there are examples where crops are similar that maybe you could get by with this, but there are certain crop combinations that would be very, very difficult to try to match that up and come up with a happy medium, for instance.